Uh, can we start?
Yes, sir, we can start.
Yes, we should start actually.
So should I share my presentation?
Sir, let me introduce you first.
Okay,
Then,
okay.
then I will make you co-host. Already you
Okay.
are co-host now. Uh, once again, good evening to all for this 10th session. On behalf of Cummins College and Maharshi Karve Stri Shikshan Sanstha, I welcome Mr. Udayan Pathak sir for this session. As you all know that this program is basically a 6-day online faculty development program on the advancement in material science. This program is sponsored by AICTE under ATAL initiative of AICTE, and the program is associated with ASM International Pune chapter. And today we have with us Mr. Udayan Pathak sir. Let me introduce Pathak sir. Pathak sir is pass out. Nikhil, please next slide. Yeah, Pathak sir is a graduate from VNIT Nagpur of 1986 batch. He has a 36 years of experience in automotive sector. Especially, he was associated with the Tata Motors. Then immediately he was the immediately past chairman of the ASM International Pune chapter. Sir is also internationally recognized experts for automotive light weighting, environmental friendly materials and processes. Usually he conduct various training programs for various industries. Participants, you might be knowing that 2 days back he was at Jamshedpur, and from Jamshedpur also he joined this faculty program. There he was conducting the the training program at Tata Motors. He has 18 technical papers to his name, which is published internationally. 75 papers in international conferences as magazine and more than 18 international and national patents. He is a fellow of Institution of Engineers and fellow of American Society of Materials as well. He is a winner of Best Paper Award in Asian Quality Congress 2020. Sir Pathak sir is a member of various bodies. He served as a member of Research and Technical Committee of BIS, then CSIR Bhopal, CSIR CMERE Durgapur, also Indo-Australian Automotive Lightweight Conclave as well. So, and one more thing, I just want to share with participants. So, because of Pathak sir, we will be able to listen to these speakers like Dr. Ravi Ravindran yesterday. And tomorrow also we will be having Dr. Naveen Manjuran and Dr. Nimbalkar, both are from ASM. And as a active member of ASM, and since we are also associated with the ASM, almost on the all occasions we have got great support from Pathak sir. So I welcome you, sir. So without wasting time, I request you to please start with your session.
Okay. Am I audible?
Yes, you are audible.
Okay. So now I will share my presentation. Only thing is my camera is not working, so probably I will not be, you will not be able to see me, but I hope you can see my presentation. Are you able to see my presentation?
Yes, sir, you are.
Okay, good.
Perfect.
So thank you, Yogesh and Prasanna sir, for such a wonderful introduction. I don't know really Whatever so many good words you showered on me, I really deserve those. Nevertheless, I'm going to
Yes,
talk to you
you
about
deserve it.
21st century materials, basically talking about the advancement in material science and technology. Actually, when this topic was given to me, it was really I was thinking that I will talk about automotive and mobility sector, etc., etc. But when I started working on preparing this particular presentation and my talk today, I went into a totally different area. And let me take you through this as to what's going to be the 21st century materials. So this I will skip because already I am introduced. So when we talk about the challenges, basically whenever you are looking for anything new, the first thing that comes to your mind is the challenges what you're looking for. And for challenges for the 21st century, if I look at the first, I mean, there are various lists, but what I feel important is the most important is the climate change, which talks about sustainability, economic challenges, then inequality, access to information and education, cyber security, and technology advancement. These are 7 challenges which we are facing as we move ahead. So if you look at sustainability is a buzzword which is coming every time, everywhere. So what is sustainability if you really look at? So if you talk about the sustainability, it is nothing but it's a balance between, let me just check what is the problem, is the balance between the environment, the social, and the economic background. It is not just about understanding that we need to change all of those, but it is understanding how they are connected to each other and to us in terms of they are beatable. These sustainable challenges are beatable, they are viable, and most importantly, they are equitable. Then sustainable development is the development that meets obviously the needs of present where we are living and without compromising the ability of future generations to meet their own needs. So this is the most important thing. When we talk about how UNO is handling this, the UNO has identified 17 global goals. They are known as Sustainable Development Goals, and these are the goals which we are talking about. And I'm going to talk about how material science is going to support some of them today. Themes such as cities, energy, food and drink, and healthcare are primarily emerging out when we talk about the 21st century materials. Need to be explored. These themes need to be explored in terms of their material requirement and our likelihood of fulfilling them. So these are acceptable themes globally. The possible directions for material science and engineering needs need to be explored, such as the metamaterials and the technical textile, along with their potential impact on the human expression in design, the fashion, and the architecture. As the number of available material increases, the likelihood that the methodology of materials development itself might evolve is being thought of. Will experiments continue to dominate is a question, or will approach that combine a big data and theory becomes more important forms of material discovery? Or the biggest thought is more controversially, will our 10,000-year-old track record of material innovation comes to an end as we run out of new materials to invent? You might be knowing recently about 6 months back, one new element is added to element table, But again, the question is, are we coming to the end? Then let us understand the area of material needs for 21st century. So again, as I said, the themes are moving around sustainable cities, energy security, food and water security, and healthcare. When we talk about sustainable cities, a primary need of a human is for the shelter and security. And satisfying this need in a sustainable way will require a growth of cities. The United Nations Department of Economy and Social Affairs estimate that by 2050, 66% of the world population of 10 billion will live in cities. A big move towards the urbanization, and they will not be staying more into the villages, but they will be migrating to the cities. Not necessarily the metro cities, but it can be B and C cities like Nagpur, Amravati, Akola, Yavatmal, like that. Many issues arise when thinking about the future cities. The first of it is whether we might run out of the materials to build them. When we say we are migrating to the cities, obviously the first important requirement is the shelter. So sustainable cities, when we talk about the first challenge that we perceive as a first 21st century challenge in terms of concrete, steel, and glass. Currently, these are the most important materials for construction when I'm talking about the mass community staying. Derived from rocks and ores that are abundant in the earth's crust. In some of the part of our country, like even in Nagpur, we are really lucky that we have a good quality of river sand for our construction, for making concrete, etc. There are few part of our countries where not only country but few part of the world where the mining of sand is not permitted, and the concrete mixture is made from the rocks and ores. Fortunately for concretes, steel and glasses, the material is really available in earth's crust. There appears to be no danger of running out of them because they are huge in the numbers, because they are in the crust. Other material required in the city infrastructure, such as copper for electrical and electronics application, for example, our security systems, etc. Then tungsten for tools which are required to, for rock cutting, for piling up of the buildings, then whatnot, and lithium for batteries, which is another way of storing the electricity and energy, are neither plentiful nor geographically widely distributed throughout the world. If you know, the lithium ores are basically in Africa, and they are being procured by China, and China is politically and commercially exploiting those stocks whatever they have. Then factors such as rarity, geographical location of ores, and the unpredictable impact of political and economic factors can and will limit the supply. Recently, we saw that China suddenly bans the export of rare earth metals about 2 years back, post COVID, and these are the kind of thing. Then polymers as a class of material will be especially vulnerable to supply risk. Probably you will be surprised to know this, but as we move ahead, I mean, you can understand why I'm making this statement. Uh, they account for a significant part of our infrastructure, not in terms of the tonnage, but because of their critical role. For example, water pipes. Nowadays, you see in the big buildings and everywhere we are using the polymer plastic pipes, water pipes. Then electrical insulations. Then plastic paints are coming up. Then various adhesives for furniture, buildings, etc. Elastomers such as rubber tires, which I mean I'm talking about the mobility solution area, which I thought probably could be the major area of my talk today. But when I studied, the picture has changed totally. Then sustainable cities, as of 2015, the feedstock for these materials was a crude oil, which is not a renewable source, which at current rate of consumption will run out in the 21st century. There are some claims and counterclaims as to whether it can be 2050 or it can be 2090 or something like that, because the estimates of exactly when this will happen depends on the assumptions about continued use of oil for production of gasoline. As you know, we are all moving towards the electric vehicles. The gasoline production is expected to come down. So more and more oil stock will be available for polymers. Presently, only 4% of extracted crude oil is used for polymer and rest is burned as fuel. When we talk about the sustainable cities, two things need to happen as oil runs out. One is we need to manufacture the polymer from different feedstock, which is currently the crude oil. And second, we need to become much better in reusing and recycling of existing polymers, existing plastic, whichever are available in the world. The manufacture of polymers from crops such as sugarcane is already an important industry and it is likely to grow. Elastomers such as rubber made from polyisoprenes derived from trees such as Hevea brasiliensis, places such as Thailand, Malaysia, and Indonesia, which are making the 44% global production of rubber, with the rest coming from crude oil. And these are the three countries which are known for the maximum production of rubber. Uh, there could be an expansion of these agriculture sources that meet the global demand of 1 lakh billion car tires per year is a big question mark. So that's everybody's worried about. It's not only that, also it is not clear that this will happen, which arises issue of regarding the cost and security of the supplies. An expansion of the industry is possible, but it would have to compete with other usage of agriculture land, which may give the social justice issues. Like, for example, more than commercial products, probably the food security is more important, and probably agriculture land will be more, devoted to that particular area. If we assume that the use of car and truck tires will reach the steady state by 2050, then an obvious solution is to recycle the used tires to make the new ones. So that's a big challenge. However, this material technology is not economically viable. Indeed, there is a growing mountain of used car tires that have no use and are mostly disposed of by incineration, by burning those tires. It seems clear then that by 2025, by 2050, we will need to have found a way to make the recyclable elastomer for transportation within cities and indeed between cities too. This work is a major opportunity for material scientists and engineers in 21st century. In fact, in Tata Motors, some of the components, when we try to find out why the sale is, some of the spare parts is going down, we realized that, in Tata Motors, we are using the virgin material because we have to meet all the legal requirements, etc. And some of the secondary market is recycling polymer, and they are using as high as 40% of the recycled polymer. So that needs to be more worked more effectively to meet all the requirements which are there on the OEM as a legal requirements. The genetic engineering of rubber trees to protect them from diseases, to increase the yield, and perhaps to make them able to grow in the wide range of climates is a possibility. That's also another area where engineer and biologists are working together to find out that we don't face any challenge in the future. Of course, there are some more examples also I'm going to give. More generally, the collaboration among materials engineers, botanists and biologists, farmers, environmentalists, then anthropologists and governments to pioneer sustainable and socially just biomaterials seems inevitable. There is no option left, but these agencies have to come together for the sustainability and for the livelihood for all of us. Such an approach to the use and reuse of material is called closed loop system, and we have to fall in line with this closed loop system. Polymer as an example of where the material community needs to move towards a closed loop, because the oil feedstock is a finite resource that all of us know, and we have been talking about. The only debate is when it will last, whether it is by 2060 or by 2090 or maybe by 2022 or something like that. I'm sorry, by 2023 or something like that. Although there is no real danger of running out of many of the other materials on which we rely, it is becoming clear that there are a number of other reasons to move towards closed loop systems. The most important is the economic. Reducing waste will save the business money, obviously, well-known commercial fact. It is known that five materials account for 55% of carbon dioxide emissions from the global manufacturing, and those materials are steel, then cement, which is used for concrete, plastic, paper, and aluminium. So these five materials, they account for 55% of CO2 emission in the globe. Reducing the CO2 emissions to reduce our risk of catastrophic climate change while allowing for the growth of cities to accumulate 10 billion people is going to be a major challenge for all of us, for 21st century material scientists also. It is further known that there is a scope for making the manufacturing of these materials more energy efficient, but only by about 10 to 20%, which is not enough to keep CO2 emissions down to low risks level. Where we are all today talking about CO2 emission. In fact, our country and Honorable Prime Minister have committed to the world that will be carbon neutral by 2030. Thus, there is a growing consensus in both the business and the engineering communities that the most effective strategy for sustainably supporting the growth of cities and the people and economies they support is to use the steel, concrete, plastic, paper, aluminium, and other materials for longer. Indeed, to design all material systems for reuse, repair, and recycling, which is very popularly called as RRR. Till now, this word RRR, that is reuse, repair, and recycling, was only dominant in automotive industry, in and mobility solutions industry. But today, it's being talked about in practically all the industries. And of course, the focus is now, as I said, is steel, concrete, plastic, paper, and aluminium, because which is contributing the maximum carbon footprint. The growing consensus in 21st century that a precautionary principle is needed to deal with the unacceptable risk of climate change means that we'll have to need to reduce the use of fossil fuel quite drastically by 2050. That's very clear, whether we like it or not. In their place will be electric energy generated from solar power, wind, and nuclear fission. Look at the vision what people are thinking about. And these are the mature technologies that are being scaled up and further developed now. It is likely that they will also be supplemented by hydrogen power and biofuels. Biofuels, when I talk about, we're talking about Jethrofa, we're talking about Karanza, etc. And in fact, those who are from Nagpur, they may know that 100% ethanol bus was first run in Nagpur. In fact, Honorable Minister for Road Transport, Mr. Nitin Gadkari, he talked to all Indian automotive industry that he would like to procure such buses for Indian automotive from Indian automotive industry, and we failed to deliver it. So finally, he went to Scania and he got those five buses, out of which one was initially inaugurated in Nagpur. And in fact, I happened to travel to that bus from airport to Sitabardi area, and that journey was offered free of cost. many material issues will need to be solved in the move toward the completely renewable energy society. Look at from the renewable energy domain. Now we are talking about a renewable energy society. We're not talking about not an individual but a society. The primary issue is that of the energy storage, and which is a really a big challenge. A solar energy is plentiful. All of us we know. We need to capture only 1% of solar flux. Remember, only 1% of the solar flux. Uh, if we talk about only 1% of the solar flux to meet all our energy needs, remember the kind of power we are wasting. 99% power is excessively available with us solar flux, and we are wasting that. Of course, there are challenges which I am going to talk in further. However, even if we could achieve that level of capture, that 1%, if we are able to convert everything into the electricity, we would still be faced with the problem of storing that energy during the day so that we could use it at night when there is no sunlight, right? And there is some very interesting thought that is being talked about in the world. Existing battery technology, although it meets our current need for mobile telecommunication, it is not up to the job. It cannot store about the 1% of the solar flux, which is the complete energy consumption of the world. This is partly because of the volume needed to store that amount of energy, but also because of the losses that storage produces. So that's the most important thing. Therefore, the electrical energy storage represents a major material research effort and is said to be continued to be so. So, energy storage materials is going to be the another area of materials. Lithium battery technologies have the greatest potential to meet automotive needs for electric vehicle in the short term. Remember, we are talking about short term and that too only for automotive needs. But other technologies based on the supercapacitors, perhaps built using 2D materials, nanotubes, and other materials, look promising. These are the areas where probably the whole world is looking from the 21st century material needs and R&D. The energy storage in the electricity grid requires a different characteristics. Unlike, now we are talking about producing electricity at one place and transporting it. Unlike for mobile applications, the weight is not an issue. Like in mobile, we can have a big weight. Now, we're talking about lighter and lighter mobiles, whereas in case of the energy grid, there is no such issue. What is more important is the power volume, capacity, and the cost. That is power per volume, capacity, and the cost. That is more important. And when we talk about this, the most efficient current technology is the pumped hydroelectric. Even in our Maharashtra, I am not sure about the other part of the country, but I'm sure about Maharashtra. When in the evening hours, when the power is at the peak demand, the power generation at Koina is improved drastically to meet the requirement, because that's the easiest way. But it relies on there being a hill or mountain nearby where the energy is being generated. This is possible only if you have the hilly terrain or mountains where you can build the dams and you can store the water, and that difference in the head, difference in the height of the water and the surrounding area creates the head to run the generators, generators, etc. So many of you are mechanical engineers, so you know better than me. The flow batteries, superconductor storage devices, pumped heat and flywheels also seems to be promising. Now, let's see how this helps us in the energy security. It is likely that mix of these technologies will be successful. Not a single, like for example, batteries or only superconducting storage devices or pumped heat and flywheels, etc. Probably as an independent technology may not be able to fulfill the requirement. So probably all of these technologies will have pie of them to support these needs. An alternative way to store energy is through the production of hydrogen, which can be used to produce electricity using fuel cells. So this is the new thought that is being emerging in the material science. The fuel cells have been in use for the specialist application for decades and are being tested for automotive applications, including we at Tata Motors are testing. Recently, Tata Motors, the Tata Cummins in Jamshedpur, they produced couple of hydrogen engines which are being given to Tata Motors, and companies are working out on that. The main issue in all these technologies are durability and the cost, because everything is ultimately driven by the cost. Japan has rolled out the domestic fuel cells to 1 lakh homes in an attempt to address cost issues through mass production. Another example which the India has, maybe with the first tenure of Modi government. If you remember, before that government, when it was formed in 2014, what was the cost of LED bulb? It was around 250 to 300 rupees. So what this government has done, they called all the global bulb manufacturer, LED bulb manufacturers to Delhi, and they said we want millions of these bulbs, and government will buy it, will give you the order right across, no corruption, you will be getting directly order. Tell us what is the lowest possible cost. And today we get the LED bulb at 60 rupees. And in fact, it was sold to such an extent that the bulbs were available on the roadside. So the cost has become affordable, number one. So if you travel to the rural area, if you're from the rural area, or if you're traveling to rural area, particularly in the night, you can see all villages are today being lighted up by LED bulbs. Even the houses, even the small houses in the in the rural areas, they are using extensively this LED bulb, even in our houses also. So this is possible, and likewise, same way Japan has rolled out the fuel cells. Domestic fuel cells combine heat and electricity outputs for the domestic environment and have reported efficiencies approaching 90%, which is a very good sign, I will say. Solar cell capacity is growing exponentially, and the solar power is anticipated to become the world's largest source of electricity by 2050, with the most being deployed in China and India. Look at this particular fact that the government is working towards this. Current photovoltaic solar cells based on the silicon are not particularly efficient or cheap. Uh, Gains in the efficiency and cost look to be on the horizon, with multi-junction thin film silicon as well as other metal system based on gallium arsenide and cadmium telluride. In fact, in 2012, Tata Motors has demonstrated a Manza car with solar roof, which was using the system based on the gallium arsenide. Unfortunately, the car has a very limited area, and it could not generate more power. And globally, Tata Motors was the second car company globally to have this gallium arsenide or solar power system. The first one was Toyota Prius hybrid model. Unfortunately, both the models are commercially not successful. Then another promising thin film technology is the dye sensitized solar cells. Again, at Tata Motors, we worked with this, but it could not see the commercial viability. This has been used since 1980s, though in Tata Motors we tried about 20 years back. They have an advantage that they do not require $1 billion clean room facilities, which makes them potentially very inexpensive to make it. Because otherwise, whatever the other technologies I talked about, uh, silicon and telluride based, etc., they need a very clean room facilities for their manufacturing. Whereas these dye sensitized solar cells can be done in any normal room. The current issues are definitely efficiency and stability of these particular solar cells. However, their flexibility and ease of manufacturing are making them a viable contender for 2030 and beyond. So a lot of people are working in this direction. In fact, in Pune, Kirloskar Group company was working out on that. Then building of the futures are likely to be coated with some sort of solar cell technology. You will be surprised to know that even in Tata Motors we did this, that some of the paints which are can be seen with normal eye can generate the power with addition of certain components, and That's what we are talking about, solar cell technology. Whichever solar cell technology wins out, perhaps even not only one which is invented yet can really work out. In fact, in Tata Motors, I had practically a museum of different type of solar cells, including the one which are used in the aerospace industry, particularly uh, spaceships, etc. But again, they have their own challenges. So unfortunately, they could not go yet well on the automotive application. One issue that is not currently being seriously addressed is the ability of solar cells to be recycled, repaired, and reused. As I said, this RRR was talked about in automotive industry, but it's not being really seriously addressed in solar cells. Today, even we get whatever the small Chinese lights, etc., which we display the panel in the our window, and then in the night we get a light, etc., for of course for the limited application. But then once it is not working, what we do, we just throw it off. That's all. No one is trying to recycle or repair or reuse to it. A serious thought has to be given in this direction for this. This will be a very important design parameter if the solar cells are to be integrated into the fabric of cities and provide majority of world's power in the future. Material science should start thinking about this issue before solar materials become a major waste stream. Today, like for example, I'm going to show you some pictures also. That plastic, what we're talking about, at some point of time, it was thought of one of probably the good solution to a small material handling, etc. But today, it has become a major disaster. So it should not become that our solar cell material becomes the major waste stream in future. Wind power is another likely to continue to grow, and especially in offshore sites. The European Wind Energy Association estimated that by 2030, the wind power will provide approximately 14% of Europe's electricity need. So, again, a very substantial number. However, the wind turbines are expensive to make and maintain, presenting a material science and engineering challenge. Now, particularly the problem is improvement in the stiffness to weight ratio of turbine blades. Materials are the major requirement and a very unique requirement of this blade material, that such improvement would allow a longer blades that extract more energy from the wind while decreasing the weight. So that is the challenge that particular industry is looking from the materials, thereby reducing the forces on the structure. Those of you who have seen the turbine windmills, how big they are. So basically, because it carries a lot of weight on the top. So if you can reduce the weight, the forces on the structure and minimizing fatigue failures can be very helpful. The carbon fiber composites are increasingly the materials for choice for wind turbines, but again, the cost is very high. Cost is very limiting factor, not particularly damage tolerant and difficult to manufacture. This is one of the design concept that is being talked about in windmill, that is damage tolerant. So if you go to the failure analysis, typical failure occurs that there is a crack initiation, then there is a crack proposition or propagation, and then there is a failure. Whereas when we talk about the damage tolerant design, that means even if there is an initiation of the crack, that material will resist to propagate that crack through that material, which leads to the ultimate failure. And of course, another challenge is the difficult to manufacture. These damage tolerant design are particularly used in the aircraft industry for the planes, aeroplanes, etc. And today it's being talked about for practically for everything, including automotive. The nuclear power will be a significant part of the future, providing, as it does, steady and dependable electrical energy. India, under the leadership of Dr. Anil Kakodkar, developed the technology of power generation using thorium. The beauty is this thorium otherwise is considered as probably the worst radioactive material, nuclear material, which is very lean, and we have very high resources. and probably Dr. Anil Kakodkar, when he was very young, and around 1960s or 1970s, a lot of work was done in this area, and we are really, it's a matter of pride for all of us that thorium, which is otherwise supposed to be a useless material, we have converted them as an energy fuel for nuclear power, nuclear power generation. Nevertheless, because of its perceived risk and ongoing legacy of nuclear waste, it is development is likely to be driven by political factors. Particularly, if you keep upon the example of Fukushima disaster of 2011, the Germany has announced that it's divesting itself from the nuclear reactors. And even when we wanted in India itself, in Maharashtra, to come out with the new atomic power stations, people started opposing it. But probably Fukushima was one of the really an odd case. On the other hand, in the world itself, the France continues to generate about 75% of its electricity from nuclear power, and by 2040, about 90% of electricity will be from the nuclear power. So it's really there for it. Although it is possible that nuclear power station designs will continue to develop with the efforts to improve the sustainability, economics, safety and reliability, and proliferation resistance of nuclear installation, the conservationism in the nuclear power industry is likely to be make slow progress as in that area, because there are a lot of environmentalists and conservationists, they are opposing this particular idea. The methods to safety encapsulate, store, and monitor the nuclear waste, however, are still at very infant stage, because you cannot just throw that waste as it is. So there are certain safety measures to be followed. Low activity radioactive waste is often stored until it is safe to dispose of. Whereas the strategy for high level radioactive waste is either reprocessing or long term geological storage, which is probably going down to the earth crust and storing it there safely. If we are not to leave a major headache to our children in 2050 and beyond, it is important that these material strategies and technologies be further developed now. As far as the energy generation is concerned, there is a joker in the pack, and that joker is today's power distribution. For power distribution in India, we have 5 regional grids. Probably those of you may be aware. They are all, the top one is north, the bottom one is south, the blue one is west, and the greenish one is east. And in the northeast, there's a fifth grid, and there the states are connected to each other to make sure that when there is a power problem in one state, they are supported by the other states. So likewise, of course, we sometimes read in the newspaper that in north grid particularly, there has been quarrel as to because of whom the frequency of 50 hertz has dropped down to as low as 35 hertz, etc. And there is a tripping of the grid, and the whole probably the region is under the danger of going into the dark. But fortunately, our western grid, in which we in Maharashtra, Chhattisgarh, Madhya Pradesh, and Gujarat, we are the part, we are doing really good. Due to approximately about 20 to 15%, 12 to 15% of the energy losses in the transmission, even Asian grid is not viable. Forget about international grid. People are talking about whether can we have the this energy loss, reduce this energy losses and grids available, so that whenever there is a day in India when, as I said, probably 1% flux of the solar power can be extracted, that power can be transmitted through these grids to US and European countries which are at the dark. Because we studied in the geography that when our country is having the daytime, the European countries and the Americas, they will have the night, and vice versa. So the people are being thought of being working on whether can we have the global or international grids. If room temperature superconductors are discovered, then a very effective and inexpensive energy storage based on this metals technology would change not just the battery technology, but it will also energy generation, as 100% efficient transmission of energy would allow the development of global electricity grid, which I was talking about, that using the solar power in India, which is daytime, US can get the benefit, and using the daytime solar flux from US and Europe to support the India and Asian countries. Avoiding the current high losses in the electric power distribution would mean that the energy generation in the geographical areas of high solar flux could continuously provide electricity to the rest of the world, which I was talking about. At present, high temperature superconductors still requires cryostat cooling to temperature on the order of 110 Kelvin, which is achievable using liquid nitrogen, but which still makes the technology mostly uneconomical for a large scale transmission of electric power. And we are looking for the superconductors which should be working at the room temperature. This is an area in which the development of new computer modeling techniques that allow the quantum mechanical calculations to be performed over a wide range of potential compounds could yield probably a very good breakthrough and a path to way forward. At present, there is no academic consensus as whether the room temperature superconductivity is actually possible. Of course, there is a need and people are talking about, so some probably unexpected things also come out of the needs. Then the next is the food and water security. Now you may feel how the engineering industry can support this. A very interesting story. Feeding the world with an estimated population of 9.6 billions in 2050 is likely to be as much of an engineering challenge as an agriculture one. It's not only the question of producing. We will see how it's even the engineering is getting involved into it. Although the world produces enough food to feed everyone, famine and starvation are still common problem in the part of the world. Such cries are likely to grow because we see sometimes there is a certain cloud burst in our country, and in certain years we found that there is absolutely very limited rains. Those are coming up. So these kind of challenges are happening. I mean, there are various reasons those are being talked of and how the people will address them, etc. But such situations are going to continue. The material science and engineering will play a major role of solving such issues through a further progress in the manufacturing of effective and economically sustainable packaging. This is the most important point one has to remember. Probably also the development of synthetic food, including meat. People are talking about this. In fact, those of you who know this Kentucky Fried Chicken, KFC, a brand which is in US, they have genetically modified those chickens, and there is a dispute whether going on whether those birds should be called as chicken, and that's why from Kentucky Fried Chicken they changed their name to KFC. One of the major roles of material science in this packaging of food, without much food is wasted. Uh, Almost all of the food and drink entering the household is contained in packaging. That is what is the need. This includes the billions of steel and aluminum cans made every year, for which the major material science issue is preventing the food and drinks from reacting with the can. No, those cans are tin coated. So this is another challenge. How do we recover those coatings, etc.? At present, this requires a barrier layers based on the epoxies, but such materials require much more work, and that's why it's not very common. For instance, some of these epoxies includes bisphenols A, BPA, what is called an endocrine disruptor that has been shown to cause an early puberty, obesity, miscarriages, and increased rate of cancers. And this is the challenge at present being faced in the Europe and Americas, and of course, in many big cities of India, these problems are very, very becoming obvious because our food habits are changing. Of course, the dose is an all important in determining whether these negative effects are observed. In 2004, the US Center for Disease Control and Prevention found the detectable levels of BPA in, most importantly, in 93% of the urine samples from people 6 years and older. So you can imagine, that's why we are nowadays talking about the people and the younger generation getting more and more early puberty. वयात येणं ज्याला आपण मराठीत म्हणतो. सो ही पिढी जास्त लवकर वयात यायला लागलेली आहे. So excluding BPA and other endocrine disruptors from all the packaging thus seems to be a sensible precaution, but engineering replacement material is not so simple. That's a challenge for the materials engineer. As of 2015, most packaging is based on the polymers derived from the petrochemicals, and as the latter run out, they are likely to become expensive. That we have seen, because now we are not sure as to when these petrochemical crude oils will exhaust. The findings replacement will be a major material science goal. Recycling of packaging seems to be an obvious route, but there are fundamentals problem. At the scale of individual households, packing represents a small portion of total waste, and for packaging to be recycled effectively, it needs to be separated from organic food waste and other materials. Many municipal corporations, I'm not sure how much it is popular in Nagpur, but in Pune and Mumbai, the food waste or the domestic waste, you have to separate as a dry and wet, and the uh, persons or the people who are collecting the waste from your house will not pick them up if they are mixed up. So they have to be separated. Also, the government has made it compulsory to buy back of the plastic pouches. So if you see the milk pouches which come to your place, there is very small line which is written at the bottom that we will buy back this pouch at the rate of 11 rupees per kg. So the buyback note is about 12 or 11 rupees per kg, and you can imagine what is the weight of the small plastic which comes to your home. It's a gram or so. So if you save about 1,000 grams, about 1,000 number of those pouches, then you will get 12 rupees. So unless really you are environmentally motivated, probably you will not follow this. In fact, I tried, but then I have to leave it halfway. So unless there is a law which makes it compulsory that if you want to say, let's say, purchase a kg of packaging material, you must buy back about half a kg or 800 grams of plastics, etc. Then only you are entitled to pack more. If that kind of law and compulsion comes, then probably we can get this answer. Uh, by its very nature, packaging is designed to be very low value, representing only a small fraction of the cost of product. What is the cost of that pouch versus what is the cost of 1 liter of milk, which in Pune cost about 72 rupees, versus if I talk about the cost of that pouch, it will hardly be 25 paisa to a rupee max, I can say. For the same reason, household themselves have a little incentive to recycle the packaging. I give my own example. I tried, but I failed. Reducing packaging might seem to be an obvious route to explore, but there is a ample evidence that packaging saves food waste. So reducing it beyond certain levels will be a counterproductive. So we know it's practically, if you remember, probably uh, in my school days, I used to buy the milk in the glass bottles from the government dairies and some of the private dairies. Whereas today I buy it in the pouch. So practically there is no milk bottle which is available nowadays. So of course there are challenges with the glass bottles also. This is not a time to talk about. We can talk sometime later. One of the outcomes of the current situation is the widespread pollution of the oceans by plastic packaging, putting all marine organisms at risk. A very people are talking about this nowadays, and this is the area where the contribution is maximum for the Europe and US. These are the pictures from the sea. From the bottom of the sea, you can see the fishes. You can see those fishes over here, and the kind of plastic it is at the bottom of the oceans. Creating a sustainable packing technology is a major challenge for material science and engineering. Many options are currently being explored, several of which are biomimetic materials approaches such as biodegradable polymers, water-soluble polymers, and natural and semi-synthetic polymers, etc. Those are being talked about. The intelligent packing shows a great promise, for example, to allow the intelligent automatic sorting of waste, but also to monitor oxygen, humidity, and freshness levels of foods and drinks so as to reduce the waste that's being talked about. Recently, one of the organization in Pune called Purnam Eco. There's an organization. No, they are working out on distribution of the food plates and the bag, this cloth bag, to the people who are expected in Allahabad, in Prayag, for the Purna Kumbh. They are expecting about 12,000 tons of food, not food waste, but the waste like plastic, etc., can be generated, which they are trying to avoid. And those of you who can join in this mission, I will request you to join. The nanostructured coatings that enhance the barrier properties of packaging films and improve the functionality of biodegradable polymers are likely to be important, and they are going to help probably in the future. The clean water for drinking, agriculture, washing, and industrial processes predicted to be extremely scarce by 2050. Even it is talked that if at all the Third World War occurs, it will occur probably because for the purpose, for the need of the water. Already in 2015, 10% of the world's population does not have an access to the safe drinking water, and 44% of the world's population and 28% of the world's agriculture are in the region of the world where water is a scarce commodity. So these statistics, unfortunately, is continuously improving, increasing, and we have to think seriously about that. The IPCC, that is Intergovernmental Panel on Climate Change, warns of coming water apocalypse by 2025. 1.8 billion people are projected to live in areas afflicted by water scarcity. So a very gloomy picture, very serious picture one has to think about. In addition, the climate models predict that the global temperature increases, the extreme droughts are likely to become more common across the large part of the world. No, we at India are really lucky, I will say, in that sense. Given that 98% of the Earth's water is saline, the ability to purify and desalinate the water is in an inexpensive and energy efficient and locally sustainable manner for water stress communities is a major goal for material science and engineering in 21st century. New desalination technologies such as membrane separation techniques based on the nanoporous graphene and graphene oxide will need to be developed well before 2050 to prevent famines, mass migrations, and economic collapses in many vulnerable countries. Particularly, we know what's happening in the Gulf countries. The next area is the healthcare. Although the most babies born in 90s did not live past age of 50, in developed economies in 2015, life expectancy exceeds 80 years. Particularly if you talk about Germany, the old people, they are growing there and they are not getting the people for healthcare. In fact, they are training people from Maharashtra and they are giving special licenses and special citizenship for the people to go to Germany to support these senior citizens. So that is creating a desire to live longer is a natural for most. But in 21st century, we are seeing a greater demand not only for the increased lifespan, but for more importantly for higher quality of life during the old age. Earlier people were just talking about, their life should be higher, they should be sustaining for the more years. But today they are talking about the quality of life. So that is the more challenging. And this translates into the desire to live healthier, independent lives for longer. Because of the various compulsions and system, our Indian joint family structure is now getting slowly collapsed because of the various reasons. And senior citizens, there are no one to take care of senior citizens. So that kind of situation. So we really need to think of that. This also creates a challenge for the material science. Material science and engineering is one of the key disciplines required to respond to this goal, and several new technologies are covering to create possibilities for 2050. Historically, the function of biomaterial has been to replace the diseased or damaged tissues. As such, biomaterials were selected to be as inert as possible while fulfilling the mechanical roles such as tooth filling, dentures, and hip replacements. These implants have been remarkably successful. In 2025, over 3 lakh hip replacement will be performed worldwide, one third in patients over 65 years of age. So this is very important, and you will be happy to know the India's contribution towards that. In Pune, Dr. H.K. Sancheti, who is the founder of the Sancheti Hospital, has developed the hip and knee replacement technology with the cost which is one third of the global cost. So that is the contribution of India, and many activities are being worked out. There is a biomedical material hub in the south, and of course, this is not the time, so I will not take more about here. The 90% of the patients can expect to have their total hip replacement functioning at 10 years, and 85% of the patients expect the replacement will be still functioning at the 20 years. So in short, the lifespan of the replaced parts is also expecting from 10 years to 20 years, and maybe going forward it can be as high as 40 to 50 years. The other parts of the body will likely to come out with this time frame, such as knees and other joints. Thanks to the development of tissue engineering, there is a potential for both hard and soft tissues to be grown to order for the patients. Much of this work is based on scaffold technology, in which the tissue scaffold is designed with the specific chemical properties and microporous structures to meet the bone density as well as to meet the specific uh, mechanical strength along with the acceptance by the body. Stem cells from the patients that are supported to grow these scaffolds using bioreactors, resulting in cell differentiation into bone, cartilage, and soft tissues as required. Bioglass was the first scaffold material invented, pioneered by Larry Hench to regrow bone. It has been in a clinical use for many years. The world's first synthetic tracheal replacement using a novel nanocomposite scaffold employing patient's own cell was grown and implanted in 2011 with a successful outcome. Of course, the cost was too high. No one yet can put limits on how far this scaffold-based tissue engineering technology can grow, because there are a lot of opportunities, what one can see. Whether it will be capable in 2050 of producing new functioning organs such as liver, the kidney, and even the heart is an open question. People are still working out this. Can this be made separately, independently out of the body, and which can be transplanted to the human body? As of now, we are only talking about some of the implants which are going into the body. Nanotechnology is providing a promising approach to develop the therapies for diseases such as cancer, in which made-to-order drugs are targeted using fluorescent quantum dots and plasmonic gold nanoparticles. The technology to modify the surface nanoparticles and to deliver them to the certain sites in the body is well in advanced. In fact, the concepts like attaching some nanoferrous powders to the cancerous cells and burning them using induction heating is also being explored. Of course, when I'm talking about the burning, it is at the micro level, so probably you will not feel when actually these cancerous cells are being burnt out. Another trend for extending the mobility and fighting the disease of old age is augmentation. This could be in the form of increasingly sophisticated and affordable exoskeletons to help the aged and infirm to get around, clothing that monitors health and delivers medicines or electronic implants that can augment vision, memory, or other human faculties. We know today we're talking about a lot of people are suffering from the dementia. So the people are talking about where there can be a specially cloth that can be monitoring the health and deliveries of the medicine so that they get rid of all this problem. The hearing aid has been one of the most successful products in this respect. We know now at one point of time it was as big as current mobile phones, but today it is a very small. Practically, even people many times you cannot see the somebody is wearing the hearing aid. So that is possible because of the materials. By 2030, 13, more than 10 million 3D printed hearing aids were already in use. So you can imagine what kind of contribution materials engineering has given. Indeed, 3D printing of other augmented station technology is likely to be a major objective, and this will require much better fundamental understanding and development of additive manufacturing technologies. Of course, a lot of activities are being worked out even in India, specifically in Pune. The printing of made-to-order devices, implants, and prosthetics in hospitals, such as 3D printed jawbones, is already happening and will change medicines quite radically by 2050. The black side of this is, this technology is likely to be used for by criminals for changing their face. They can commit a heinous kind of act, and they can change their complete jaw using this 3D printed jawbones, and probably they can hide their identity, and this is going to be another challenge. There is an ongoing convergence among the medicines, biology, and material science, and ensuring that collaborations work effectively will be the key to the progress. Yet, this is not as straightforward as a fundamental challenge or change in what research is carried out and for whom is likely to be needed if full potential of biometals is to be realized. This is how I look at 21st century materials. Advancement in material science and technology will happen, and India will be the forerunner in this direction. So, with this concluding note, I stop here. And if at all any questions and all are there, I will be glad to answer them.
Participants, the forum is open for question answer. If you have any question, then you either you can raise hand or can type in chat box as well.
Only Prasanna, you will have to help me to read the questions because
Yes.
I have a problem in my laptop, so I'm not able to see everything.
Okay, no problem. All are saying nice presentation. One question is polymer composites are the future materials? Dr. Dilip Kumar Biswal, you can unmute yourself.
Yes, sir.
Ah,
Sir, one question is that
Yeah.
now we are using polymer composites.
Yeah.
Is there any futuristic material for our 21st century?
Yeah. See, actually, if you remember, I spoke about the polymeric material. Today, the base stock is the crude oil that is being used. Okay.
Sir.
And as it is, we are worried about the how much years it will sustain, and we will be able to survive with the fuel and all that point kind of thing. So yes, probably for a couple of years it will be have a good opportunity, but unless we have some alternate base stock from which we can derive the uh, polymer, like for example Jitropha and Karanj, etc., it looks difficult. On the longer perspective, I really doubt.
Okay, sir. Thank you, sir.
So what are the challenges in for superconducting materials, sir?
Okay, Harinath sir. Okay.
Yeah, will you
What are the
please repeat the
challenges
question?
in producing superconducting materials, sir?
Yeah. See, when I'm talking about today, we are talking about the power generation at one point. Like, for example, I will give the example of Maharashtra. Maximum power is being generated in Nagpur, Chandrapur. When I say Nagpur, it is Koradi and Khaparkheda, then Chandrapur, and all those places where we have got the thermal power plants, and the maximum utilization is in the industrial belt of Mumbai, Pune, Nasik, all these areas. So that is possible because we can, take electricity from one place to other. We
Yeah.
have we are fortunate that the states like Himachal Pradesh, where using the same water stream, multiple hydropower stations can be erected. Even currently, they are erected, and that hydropower is generated. But unfortunately, carrying that electricity from Himachal Pradesh to probably down south to the Tamil Nadu is a problem. So there probably the surface, this superconductive material probably can help, and then even we can think of the combination of superconductive materials and the solar PV, photovoltaic material, so that we can tap the solar power and transfer energy from one place to the other. Maybe India can become the energy farming station for that matter.
Okay. Okay.
Good
Thank you.
evening,
Thank you.
sir. Good evening, sir. Myself, Dr. Mukund Patil.
Yeah.
I am a HOD and Dean R&D at GH Raisoni College of Engineering and Management, Jalgaon.
Okay.
Sir, I have one question that how I can associate with ASM actually.
Okay. I think we can talk offline because probably uh, I will get your number from Professor Dandekar and the other team from Cummins College,
Okay.
Nagpur, and we
Okay, sir.
can talk offline, and definitely we will support you to start that chapter there.
Okay, sir. Okay, sir. Thank you, sir.
Dr. Patil, in chat box, I have given my number. You can
Okay,
DM
sir.
me.
Okay, sir. I can copy. Okay, thank
Yogesh,
you.
Sure,
you
sir.
can
Thank
share
you.
my number also.
Yes, yes, I'm sharing.
And of course, Dr. Patil, Yogesh will be your first contact. Of course, I am there anytime to available. I am available to help you out. But
Okay, sir.
in that area, we are, requesting Yogesh to take care of, starting new chapters, etc. So Yogesh will be the right person. Of course, as I said, I am available to you.
Okay, sir. Thank you, sir. Thank you.
Yeah.
Sir, good evening, sir.
Good evening.
Good evening. Sir, first of all, I would like to thank you for putting a very nice vision about the development in the materials required, particularly in 21st century, in the various sectors.
Yeah.
Sir, one question I would like to ask you that we are nowadays we are going for the renewable energy sources, and again we are talking so much about the solar energy. But can we say the solar energy is a sustainable source of energy, or it is a sustainable development?
Yes, it is, because see, for whatever you do,
The reason is the material which is required in production of the solar panels that we have to consume. So, will
no,
it
so
take
that
care of the
so,
sustainable development or the?
so that is what is the challenge, that in solar industry also we need to come up with the RRR concept effectively. Number one. Second thing is the other materials which I talked about, selenium, telluride, etc. There are certain materials which are coming up, who has got the better efficiency, etc. That is being talked of. Today there is a challenge definitely, and a lot of scope to work in that area. Because at some point of the time, definitely this coal and all these kind of things are going to get exhausted, and the probably only chance available to will be some sort of nuclear power and hydraulic power and hydropower.
Yes.
And third thing can be the solar power and windmill. Of course, windmill again has limited scope, because you need a particular topography of the
Yes.
land, and you have to have that wind direction, strong winds, etc. So those are the challenges. Whereas in case of thermal, as I said, like when today we are talking in the night in India, our counter countries in US and US etc. Europe etc. They have probably full daylight, and we can support each other. Probably India can be forerunner in that.
Yes. Okay, sir. Thank you. Thank you very much.
Any questions? Okay, anyway, sir, shall we conclude?
Yes, thank you very much for giving me an
Huh.
opportunity to share my thoughts. And in fact, while preparing for this lecture, I made one, kind of rough skeleton that I am going to present in this way. And when I really started preparing, my presentation got totally changed. And in fact, it was a learning opportunity for me too, not only for the faculty who are joined this faculty development program. So thank you, Prasanna and Yogesh, for giving me this opportunity.
Actually, sir,
Thank you,
the
sir.
participants are faculty members. Harinath, sir, you want to say something?
Yeah, sir. For the solar photovoltaic cell, what is the better material than silicon, sir? Any better material?
Okay,
Is
as I
silicon
said, I will show
current?
you some bismuth, telluride, etc. These are being talked about. People are talking. Maybe I can share this presentation with you, wherein all those details I have given. There are people are talking about dye sensitized cells, etc. So some little more details will have to go into the materials.
Right, 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 sir. Right.
Uh, Fine. Harinath, sir?
Right, sir. Thank you.
Okay, sir will share the
Prasanna,
presentation.
sir.
Huh.
Prasanna, sir, I think tomorrow we will be having some online feedback. So we can appeal the participants. If
Yes.
anybody is interested, they can contact both of us.
Yes. Dear participants, okay. Am I audible? Yes. We have WhatsApp group as well, and all of you have my number and Yogesh Dandekar sir's number. Please come forward and share feedback, give a feedback to us, because we have tried our best to give you the advancements in material. You probably got to know that all the sessions were really advanced. Somehow, many scholars, they are actually working on the advancements. Some are working on the analyzing part. That's what we thought, and we tried to give you. So please give us the feedback tomorrow. Pathak sir, all the participants, they are faculty members. So whatever you have shared, that will directly percolate to the students level.
Yes,
And
thank you very much for that.
actually, that is the motive for this faculty development program. Ultimately, we work in a chain. Uh, so once again, thank you for sharing your thoughts on the green materials. And again, I thank all the participants for patience listening. Tomorrow at 2 o'clock, we will again meet. Tomorrow, we will be having three sessions starting at 2 o'clock. And second session will be at 3:30 and third at 5. And I appeal all the participants to please give a feedback tomorrow. So
Sir,
thank
excuse
you.
me, sir.
Huh.
Sir, how can I join your WhatsApp group?
You are not on the WhatsApp group. All the
No,
participants are on the group. Oh?
no, I am not there.
Okay, sir. I will add you.
Okay, thank you, sir.
I will.
That's why I am surprised.
All right. I think I missed you. Many are
Okay,
there on the group. Maybe your setting is
no,
different.
I have not received any link also regarding that.
Okay.
Please,
So
sir, add me.
okay. No problem, sir. I'll add you.
Thank,
Okay.
thank you, sir.
Thank you. Ah,